Good morning, everybody, and welcome to this Routing Security Webinar hosted by Telia. And this will also be an introduction to the MANRS initiative. This is something that's being sponsored by the Internet Society. But just to introduce myself, I'm Kevin Meynell, and I'm the Senior Manager for Technical and Operational Engagement at the Internet Society. And one of the projects that I'm working on is the MANRS Routing Security Initiative. So this morning this is a two-part webinar. And this morning I'm going to run through the introductory part. So this is going to cover what is routing and why is it needed. This won't be a really in-depth dive into how routing works, but it's a very brief introduction if you're not familiar with routing itself. I'm going to explain a little bit about what the routing problem is and why you should be aware of this and why you should be interested in some of the issues. And then I'm going to talk a little bit about what can be done to fix the routing problems. Why is routing security so hard? What routing security controls can be implemented, and who should be doing this. Finally, I'm going to give an introduction to MANRS itself, the MANRS initiative, and I will give a demonstration of a tool that we have called the MANRS Observatory. Next week, we have a second part. This will be will be next Tuesday, March the 9th. This will be covered by my colleague Aftab Siddiqui, and this is much more of an in-depth technical dive. So this will cover routing security in much more detail and how you can implement some of these routing security controls. So that's the very brief overview of the agenda. So quite a lot to get through, so I will dive straight in. Dive straight into what is routing and why is it needed. I appreciate there's probably a number of network engineers on this call. I don't want to bore you too much with the basic details, but in case people aren't aware entirely of how routing works, it's a very short introduction. But there are around 71,000 networks connected to the internet. So by this I mean autonomous systems. So these networks are identified by a unique autonomous system number. These 71,000 networks, there are around 10,000 multi-homed ASs. So in other words, networks that are connected to at least two and sometimes more other networks on the internet. So you can see the vast majority of networks, over 60,000, are actually what you would say sort of end customer networks. But that 10,000 is actually quite key because that's one of the sort of targets that we're interested in. So all of these networks, they use something called Border Gateway Protocol to exchange the reachability information. In other words, the networks that they know how to reach. And from these, the routers build a routing table in order to pick the best route to send packets across the internet. So pretty much all of these networks will have a router. All of these routers, they use those routers to connect to the internet, and those routers exchange the reachability information. So BGP uses 32-bit AS numbers to identify themselves. And in case you're wondering where these AS numbers come from, these are issued by regional internet registries to what's called a local internet registry. Now, a local internet registry will normally be an internet service provider. Sometimes it can be a very large enterprise, sometimes a government department, but it will be unique on the internet. In the case of Europe, in the case of Sweden, it will be you'll go to the RIPE NCC for that number resource. Then you also have IP prefixes, which are blocks of IP addresses, which I guess most people would be familiar with, and these are linked with AS numbers, which are used to decide routing policies, or in other words, where traffic can be sent. So The more observant of you may recognize that this particular IP prefix belongs to Telia, and also the AS number 1299 is a Telia AS. Telia actually has a number of ASs as a large network, but for the purposes of this example, I just used some of their main AS and one of their prefixes. So the ASNs and the IP blocks are collectively known as number resources. And I already mentioned there were 71,000 AS numbers, but there are around 866,000 IP prefixes being routed on the internet. Yeah, those were the sort of effectively the number of destinations possible on the internet. So what's the problem with routing? Well, one of the main reasons is that BGP is inherently based on verified trust. It was devised back in the late 80s and was pretty much reached its current state sort of early 90s, early to mid 90s. And it's actually been a pretty reliable protocol. It works really well. It's generally pretty reliable. But it was devised in an era when there was more trust between networks. There were less networks. Generally, network operators knew each other a lot better. There was no need to have verified trust. So as an upshot, there's no built-in validation that routing updates are legitimate. And essentially anybody can announce anything on the internet. If you've got a router and you've got a connection to the internet, there's really nothing to stop you announcing any number resource, whether you actually have the right to do that or not. And as a result, for various reasons, malicious reasons, but also accidental configuration reasons, the routing system has finds itself under attack. So this is an attempt by CADA. So this is a project based at the University of San Diego that attempts to do a lot of traffic measurements of the internet and do a lot of mapping of the internet. And they have attempted to draw a map of the internet. This is to some extent trying to be geographically correct insofar as you can do this with the internet. But it really tries to show all of the different relationships between all of the different networks that constitute the internet. In the middle there, you can see where the sort of denser area, that's pretty much the tier 1 networks that have connections to most of the other networks on the internet. As you go out towards the edge, they would be the customer edge networks. Now, you can pretty much see that this is a complete mess, like a big spider's web, a very dense, complex spider's web. And I use this diagram just to illustrate the complexity of all the sort of different relationships that would need to be maintained on the internet, and the issue of trying to verify, who is on the other end of the connection, and that's really what we're trying to address here. So there are 3 main types of routing incident that cause problems. I'm going to delve a little bit more into these in next slides. But there's something called route hijacking. You have route leaks and IP address spoofing, which is probably more familiar to the average person, the lay person on the internet. All of these incidents, you can find real examples of significant problems. But there are also problems. We see these problems every single day of the week. I'm particularly looking at this every week, and certainly I could pick a random network and I could see a route hijack. I could see a route leak somewhere. Address spoofing I have less visibility into, but that's certainly also happening on a regular basis. So what is a route hijack and a leak? Well, this is the illegitimate advertisement of prefixes, so in other words, blocks of IP addresses that basically direct internet traffic from its intended path to somewhere else. The difference between the two is that a route leak is usually accidental, whereas a route hijack is usually intentional. It's done for deliberate purpose. So just a sort of quick run through, if you're an end customer or a customer network, your upstream provider may well be saying, okay, I can take your traffic to Google, which is where a lot of people will be wanting to get to. But let's say that you had a multi-homed connection. Another provider could also make that same claim as well. Now, the traffic may well still reach the end destination, but you may not want your traffic traversing that particular path, or you're not sure where that traffic may end up. And that sort of is the fundamental issue here with routing security. So we have this sort of overview here of a route leak. So we have this customer down in the bottom, which is AS64502. It's trying to get to Google, which is 8.8.8.8. And normally this would traverse up to its upstream provider, which is 64500. That would head across the internet over to Google. Now, down in the left-hand corner, you have another AS, another network. So that's 64501. That normally, the other AS doesn't want to send its traffic through that particular network. But because of a lack of controls, this has misadvertised the fact that it can reach Google. Now, there is a connection there, and because it's made this announcement, under certain circumstances, the traffic can traverse through that network, back up through the internet towards Google. Now, in some cases, this will reach the end destination, but in some cases, the resources, the routing resources, or the end systems at that particular network may be inadequate. The connection may be inadequate for the amount of bandwidth traversing it, and that can cause problems. Now, the classic example was back in June 2019, where a network provider in Pennsylvania accidentally leaked a route to Verizon, which is a very big service provider, as I'm sure everybody knows, and that ended up directing a lot of traffic to a power utility company in Pennsylvania, which essentially acted as a denial of service attack. Not intentional, but the effect was a denial of service attack, and traffic would black hole into that particular destination. So then you have route hijacking. So again, as I mentioned, this is more intentional. So this is where a network operator or attacker is impersonating another network operator, or pretending that the network is their client. So this is routing traffic to the attacker, and the victim gets an outage. So again, down in the left-hand corner, AS64501 wants to send its traffic to Google, or send and receive traffic to Google. But this other attacking network up in the top left-hand corner is announcing the same route as the network in the bottom left-hand corner. So again, the effect is that traffic is being sent to the attacker. And that can be done for blackholing reasons. It can be done for reconnaissance reasons. It can be done for man-in-the-middle attacks. What you'll often find is that route hijacking is sometimes done for censorship reasons, that in particular countries, the telecom company or the ISP, the large ISP, is asked to redirect traffic to a particular destination, to a black hole. There was a very famous accidental misconfiguration with respect to YouTube back in 2008, and that actually caused a lot of YouTube traffic to be dropped from around the world because of this attempt to censor traffic to and from YouTube. So these are real issues that you see. Sometimes you'll see a big incident once or twice a year, but this is happening every day of the week. And then you have IP spoofing. So there's sort of two main issues here. So this is where a sender of a packet sends a forged source IP address. So in other words, it sends to a particular destination, but in order to route packets back to its own source of origin, it will put in a source IP address. Now, normally that will be legitimate, because obviously you want your packets to come back to your network. But in some cases, you can put in a forged source IP address. And if there's no source controls of this, this cause issues with respect to, you can use it for application level attacks. You can use this for denial of service attacks. This is often used to mask the origin of, for example, botnet attacks. So there's a number of reasons why attackers would want to do this. And it masks the origin of the attack as well. So we also have reflection attacks. So this is typically distributed denial of service. So this is where you send a packet, or an attacker sends a packet to a convenient reflector source. So again, typically this would be a DNS server. It can also be an NTP server. There's other sources of reflection that could be used, but DNS is a typical one. So a packet gets sent, say, with a DNS query with a spoofed source IP address. The spoofed source IP address is of a victim computer. So say, for example, the DNS server will receive all of these requests and send them back to a completely different machine, which is the intended victim, and that's the origin of a lot of most distributed denial of service attacks. So again, not a good thing to be allowing emanating from a network. So again, this is just an example from, I think, a 7-month period in last year. We pulled this from BGP stream. So this is not even leaks. This is BGP hijacks, or suspected BGP hijacks. And as you can see, yeah, there's something happening every day over that period. And you can sort of see the scale of this as well. Okay, so that's the basic explanation of what the problems are. But what can we do to actually fix these problems? Well, maybe we need to sort of give an explanation of, okay, these problems are well known, they've been well recognized for many years, but why is it still happening? Why is routing security so hard? Well, part of the problem is that every operator needs to contribute to routing security. But in fact, there's actually very little incentive to do this by yourself, because implementing routing security measures doesn't actually bring immediate benefits for an individual operator. Really, that everybody, or at least a majority of networks, need to be doing this for this to be effective. So it's very easy to say, well, okay, if I do this, it doesn't bring me any particular advantage. It's just extra work. The other problem is that routing incidents can be really hard to identify and debug. I mean, I was a little bit surprised by this myself, but it's really quite surprising. But even very large networks just simply are not aware of that they have routing incidents, and they're not aware of where they're occurring. Once we started to put together this MANRS observatory tool, it actually became a lot clearer for a lot of operators where these issues were and what they needed to fix. So that's also been sort of part of the problem, having really good tools to identify this stuff. It comes back to, it needs collective action, and that's what we're trying to achieve with MANRS. Now, the internet operates very significantly on the basis of norms. There's certain things that you do on the internet that everyone recognizes that need to be done to make it work effectively, whether that's email, whether that's web browsing, websites, web security, DNS security. There are some things that are widely accepted as good practice. Now the issues with the DNS, for example, have been well known for a long time. The issues of security with websites has been well known for a long time. And in the last few years, there's been a huge push on implementing things like DNSSEC and things like TLS, and these have become much more of the norm than perhaps they were 10 years ago. But we haven't really got there yet with routing security, and we need to. That's what the sort of thing that we need to shift the paradigm. We need to shift the paradigm here. So we need to accept that there are some things, there are certain practices that should be done and should become the norm on the internet. And basically, what this comes down to, it's very simple. It's, do not accept and propagate the mistakes of others. So in other words, validate what you accept from other networks. So in other words, protect your neighbors from your own mistakes. For example, so not through allowing hijacking and not through allowing leaks on your network. The other important thing is to make sure that your number resources, so that's your AS numbers and your IP prefixes, those are up to date and those can be validated by others. And there's actually two main ways of doing this. One is through internet routing registries, and the other is using RPKI, which is, I would say, slightly newer, although it's still been around, still been possible for about 10 years at least. So routing security controls. Going back to our diagram of one network masquerading as another network, but there are things that you can do. So for example, if the network that you wish to reach actually has its number resources registered either in an IRR or through RPKI, through the RPKI system, that customer network or the originating network can actually validate that the announcements are correct. They are coming from where they should be coming from. So it's really important to look at the IRR and the RPKI side of things, because that is what's allowing other networks to validate your number resources and that you're authorized to originate them. So again, they both sort of effectively do the same thing. IRRs have been around for quite a long time. So there are a number of these, no pun intended. So you have, for example, all of the regional internet registries operate an internet routing registry, and they put in the IP prefixes and the AS numbers into that. This is sort of meta-aggregated by one of the original IRRs, RADB. So these are all effectively synchronized. The problem with the Internet Routing Registry is that basically you have the similar problem that pretty much anyone can put anything in there. And perhaps the bigger problem is that you have to, a network actually has to actively update that information. So let's say they acquire another IP prefix, or they change a prefix, or they acquire another network with those number resources. That all needs to be updated in the Internet Routing Registry, and it's very easy for that to get out of sync or for things not to get registered. And typically what you find is that IPv6 resources are not registered. That's a very common thing that we see. RPKI, this is where this is maybe a more effective system. So this is where you make a cryptographic attestation that you're allowed to originate a particular prefix or a particular AS number, and that can be cryptographically verified through a PKI systems that are ultimately operated by the regional internet registries. So, for example, Telia AS2199, they're allowed to originate 103.47.204/22. This is basically either system can validate. So who can make the impact here? Well, certainly anybody that's operating a network connected to the internet that has an AS number, for sure. But we're also looking at, in particular, transit providers such as Telia. They can have a really big impact on this because they're carrying a lot of traffic from a lot of networks, but also IXPs. So IXPs are obviously interconnecting multiple networks. So they can have a really strong role in encouraging their members to implement and undertake strong routing security measures. And then last but very much not least, we have content distribution networks and cloud providers. So most of those actions they can take are very similar to the network operator actions, but there's a couple of very specific actions that they can take as well, which I'll touch upon in a moment. So this brings us to MANRS, mutually assured norms for routing security. So what we're trying to do here is really bring together all of the best practices that have been around for quite a long time on the internet and bring these together into some well-defined actions which can help, hopefully eliminate all of the most common threats to the routing system. So this is nothing new under the sun. All of these things are well-known practices, but one thing that we're trying to do is bring this together in a sort of common package and say, right, if you perform 3 of these 4 actions, this will have a real impact on improving routing security on the internet. And it's really about participants, so network operators, IXPs, cloud providers, collaborating together and taking some shared responsibility for the security of the internet infrastructure. And certainly in the past few years, there's been active measures to improve, as I say, DNS and web security and mail security and various other aspects. But this is something that really hasn't been hugely addressed up until quite recently. So what we have is 3 programs for 3 separate programs for network operators, IXPs, and cloud providers. And what we're trying to achieve is everyone benefiting from improved routing security. So encouraging networks to implement these routing security practices, but more specifically also raise customer awareness so that they actually will demand this from their providers, maybe even distinguish who they're getting their internet service from on the basis of, well, are these guys performing good routing security practices? But this isn't about stick as well, it's also carrot. So we're also there to help networks easily identify and address a lot of the problems that we see. So that's where the MANRS Observatory comes in, which I'm going to do a short demo on. And the aim is that the more operators that apply these actions, the fewer incidents that they will do, that will occur. And actually there is some evidence that as operators have applied these actions, that we have seen a drop in routing incidents. And then we also want to develop a sort of historical database of incidents to sort of demonstrate whether we can identify where there are particular problems, but also whether we can see things improving over time or not. So are these measures actually being effective? But ultimately, really to build this self-regulating community of security-minded operators who are really committed to making the routing infrastructure more secure. So I'm not going to go through the actions for every program, but I'm just going to touch upon the actions for the network operators program, which is by far the largest. So here there are 4 actions. So action 1 is filtering. So this is really about preventing propagation of internet routing information. So this is ensuring that you're only announcing the announcements from your network and also those of your customers, that those are correct. So you're not announcing things that you're not authorized to announce. I'm going to skip 2 for a moment. I go on to action 3, which is coordination. So this is very simple, making sure that you maintain contact information usually in an RIR database to make sure that people can contact you and that contact is responsive, and that you undertake, if you do have a routing incident, that you will respond to that within at least 72 hours and hopefully much faster than that. And then the 4th action is global validation. So this is making sure that you publish your number of resources in either an IRR or using RPKI. Coming back to action 2, so that's anti-spoofing. So at the moment, this is an optional action. So this is networks should prevent traffic with spoofed source IP addresses from emanating from their networks. So whether that's from your own network or from a customer network, you're making sure that they're not forged IP addresses on the packets. There's various reasons why that's optional at the moment, but ultimately we would like to move towards that, strengthening that as well. In interest of time, I'm not going to go into the other actions for the other programs too much. The IXP program, there are some of the similar actions there. There's other ones that are very distinct to IXPs, but just to be aware that those exist. And then similarly for CDN and cloud program, most of those actions are very similar to the network operators, but there's a couple of extra actions there as well. Just to mention here that if you haven't implemented routing security measures yet, if you haven't implemented MANRS, we do have some technical guidance here. We have the implementation guide for network operators. And there's for each of these actions, there's configuration examples, there's explanations of how you can implement these, all of these things. This is based on best operational practices developed from network operators around the world, and it actually has recognition from the RIPE community as RIPE 706. So again, it's a good source of information. We're just in the process of updating that at the moment, and process to make sure it's all up to date. One thing we needed to add was the LACNIC IRR configuration examples, and there's a few other things, but yeah, it's still quite a good source of information there. And briefly mentioning, we have some training modules on this as well, which goes into a bit more depth of how to implement some of the MANRS action, well, all of the MANRS actions. Okay, so I'm going to just give a brief demo on the MANRS Observatory here, but a quick explanation of what this is. So this is a tool that we developed to impartially benchmark ASs, really to improve the transparency of this process. In the early days, we were having to sort of rely on people's networks saying that they'd implemented what they said they had, but this tool actually allows us to check that. Well, it also allows others to check that, which is the perhaps more important thing. So really to give this sort of factual state of security of the internet routing system, but the most useful function is at the moment is to allow MANRS participants to actually check for their own conformancy with these routing security actions. This is not data that we're effectively generating ourselves. This is coming from a number of publicly available data sources, so particular BGP stream, the CIDR report, the CADA spoofer database, which that's the only anti-spoofing is the only thing that we can't measure passively from the outside of a network. It does require a network to actively run the CADA spoofer software so that CADA can look for spoof packets. That gets recorded into their database, and we pull that information from them. And then we look at other sources of data like the RIPE database. This peering DB is also a really important source of information. The various IRRs, and of course, yeah, for the moment, RPK validator, but that will change. That's going away in the future, but we'll find some alternative for that. Right, so I'm now going to just switch to give a sort of hopefully a live demo, if I can, of the MANRS Observatory, and hopefully everybody can see this. So when you go to, so this is at observatory.manrs.org. Anybody can go to this URL and look at this information. And you'll come initially to a dashboard that will show each of the 4 MANRS actions as these sort of blue circles here. And that really sort of indicates the conformancy with each of the 4 network operator MANRS actions. Action 4 is split into 2 components. So IRR and RPKI. So that's action 4 is actually these last two. Now this is looking at the global view here, and this is the global view for March. We can actually go back and look at other months as well. We can go back, well, I think we've got nearly 2 years worth of data here. And you can sort of look at the sort of conformancy scores. So we actually collect much more information than this, and I will go into that detail in a moment. But the idea is to kind of give a very sort of simple conformancy check for either one network or groups of networks. So here we're looking at the whole world. You know, we can sort of see that yeah, in terms of routing incidents, you know, actually there's a relatively small number of problems that affect a relatively small number of networks, but of course with 71,000 ASs, even, you know, 1% is still quite significant. You know, you're sort of looking at most networks in the world have registered some sort of contact information. Again, similarly with their IP prefixes and routes, you know, vast majority of networks have registered those in an IRR. But then, of course, we look at RPKI, and that's maybe less good. Uptake of that's been quite slow. It's increasing, but still quite slow. But we can do this by country as well. So I can look at Sweden, and Telia being Swedish network. So again, these are the sort of figures for Sweden. You can also click on this by click on the country as well. It's okay for Sweden, that's big enough. If you're looking at Monaco, that's a little bit more tricky. Trying to hit it, so you can just type that in at the top, the name. So Sweden's doing a bit better. You know, it seems to be 100% for contact information. IRR, it's sort of around the global average, and actually better for RPKI as well. Again, 30% is not fantastic, but it's definitely better than the global average. We can actually do this by different regions as well. If you're interested in how Europe is doing, or the right region. So these are the same information for the bright region. It doesn't change hugely region by region. You can do it by UN region as well. So you could look at Europe, all of Europe, depending on how you define Europe. But okay, that's all very nice. But you know, and instead you can aggregate data from a custom set of ASs as well. But really, you want to know about your own network. So I'm going to go to Telia here, and I'd say Telia has a number of ASs, but I think this is probably the main one. And this gives you a score for Telia, and this is perhaps much more interesting. Now, I'm going to prefix this with a caveat that Telia is a tier 1 provider. They take traffic from a lot of places around the world. They also joined MANRS when the requirements were slightly different than they are now. And I will explain why their score is only 49% for filtering. There are reasons for that, and it's not necessarily bad reasons. So I don't have we don't have spoofing data for this particular month. We do have it for previous months. You can actually go back and look at the history of Telia's sort of conformance scores. So they obviously ran an anti-spoofing check back in May, June, July, August last year, and also in October, and that they scored 100%. So they're doing, it looks like they're doing anti-spoofing measures based on that, from what we can see. But yeah, just coming back to here. So again, they put their contact information in. Pretty much they've registered all their routes, which is good. And actually they're doing pretty well for RPK as well. There are good reasons why that may not be 100%. For example, with legacy prefixes, there may be customer prefixes that can't be registered. So there are probably reasons why that isn't 100%. But I can actually look at the details for this, for Telia, and go through, and I can find out, you know, have they had route leaks? Have they had route hijacks? And, you know, sure enough, we can see it's possible, and I will use the word possible here, there've been possibly a number of route leaks from Telia and possibly a number of route hijacks. I will point out that BGP stream throws up false positives. Some of these could well be, and possibly are, probably are false positives, but it does give you sort of an idea to where to start looking. You can look at, okay, why is that prefix? Why is that being flagged as a route leak? The same with a route hijacked as well. They look like they've been a few route hijacks from a similar group of addresses, but you can actually look where the path through the internet here, and if you need more information, you can go to the BGP stream ID and check the original source of data. Bogons, okay, we're less concerned about bogons because there's reasons for bogons sometimes. So these are resources that should never be routed on the internet. But what we find is that a number of the regional internet registries will actually mark some legitimate number of resources as bogon, perhaps if the biller hasn't been paid or if they've lost contact with the holder of those resources. So they're not kind of real bogons, they're just administrative bogons. This looks like somehow there's a default IPv6 route has been advertised on the internet. I'm not sure why that's there, but that's pretty clear, that one. And then there's a number of other prefixes here. Yeah, some of these, I did check some of these, and these are North American prefixes, or they're from registered with ARIN, and I suspect they're administrative bogons there. But we can do this for every action. So we could look for anti-spoofing. If there were spoof packets coming from Telia, we could check where they were coming from, but they haven't had any, or we haven't got any information for this month. And then unregistered prefixes here as well. These are the list of prefixes apparently unregistered by Telia in an IRR. Often you'll see IPv6 prefixes here, but yeah, these are all IPv4. And you can also look at, okay, what prefixes do you not have rowers created for? And if there are invalid ones, which you sometimes see, they will show up and you'll get a list of those as well. So that's, you know, it's a pretty powerful tool, this, and you know, it does help identify where there might be some problems. And I'd like to thank Telia for allowing me to use this information. And I hope I've explained, you know, why they might not be 100% for everything in the observatory here. Okay, I'm going to just quickly switch back, and hopefully you can see these slides. Yeah, so just to say that at the moment, the public can view all of the aggregated data that's publicly available. At the moment, only the MANRS participants can see the detailed data about their own networks. But if you're interested in joining MANRS and you have potentially some things you want to work through, we can also create an account which will give you access to your own details as well. So that will help you work through those particular issues. We can give this to CSERTs as well for any networks in their constituency, also for, you know, critical infrastructure sort of agencies. We have done that as well, and also, you know, legitimate researchers. We can give the full detailed access to in the observatory. And I already sort of discussed these caveats. You know, there are still some false positives, particularly with BGP Stream. We're working to fix some of those things, and sometimes there's good reasons for non-100% conformancy. But at the end of the day, this is all publicly available data anyway. Okay, so now just to see, okay, you know, so that's, you know, the overview of the MANRS program and MANRS initiative. That's an overview of some of the things we've been doing. The tools that the observatory tool that you can use to sort of identify where these problems are. But it's maybe just sort of, yeah, useful to say, you know, is this actually having an impact? And I think it is. So at the moment we have, last year we saw a huge growth in MANRS participation. Despite all of the COVID issues, it seemed to be a good opportunity for networks to really get their routing security in order, and we saw a sort of huge spike in participation, which is a really positive thing, and actually from some really large ISPs as well. So that's really good. I would point out that Telia was really one of our founder participants, so they've been a member for quite some time. But yeah, certainly so 530 ISPs, and that's about 600, constituting about 650 ASNs, 63 IXPs, and then the cloud program that's only started sort of middle of last year. That's actually now up to 20 participants there. So certainly in terms of participation rates, we're doing quite well. But the important thing is, is this actually having an impact on incidents? And the evidence suggests that it probably is. As the number of networks participating and actually applying the routing security measures have increased, we've actually seen a marked decrease in incidents, and I think that probably is a positive thing. And of course, a lot of networks, even if they're not actually MANRS participants, they have started to sort of take routing security seriously and are implementing these practices. So that's also having an impact as well. So yeah, so the evidence suggests, this is still early days, and you can draw certain conclusions from this, but yeah, it does seem to suggest that there is some positive impact here. Right, in the interest of time, I'm going to stop here. Need to except to say that MANRS is actually, even beyond the network operator community, is really starting to gain some visibility and credibility. We're getting mentioned in the media, and actually even in government circles, which may be a good or bad thing, I don't know, but at least people are aware that this is something that's important. And certainly, the really important thing is networks are saying, we really should join MANRS, and we really should implement these practices, and that's really good to see. But if you're interested in joining or participating, please go to the MANRS website. If you're ready to join, even if you're not ready to join, you can still make an application, and we can sort of give you access to the observatory. We can work through any issues you may have, and we can take that from there. So yeah, please consider joining the community. So with that, I will pass back to the moderator.
Perfect. Thank you so much, Kevin. So we have gotten in a couple of questions during your presentation, and I was thinking that we could walk through a couple of them right now. So first, a practical question, whether the presentation and the slides that you've shown will be available for download. And I think that, yes, a version of these slides can be available afterwards.
Yes, that's no problem.
Perfect. And I think also you just covered, we received a question here, how you request access to the observatory and how you do that. But I think that the slide that we're currently seeing is answering that question as well. Yeah,
if you just send, I think it's I think it's on the website. I hope it's on the website. But if not, if you send to manners@isoc.org, we'll pick it up. If you send an email to me, I'll pick it up and we can arrange access. Perfect.
And then we've received a question whether, so it's about the impact that COVID-19 may have had on the internet in general in terms of changing usage patterns and people working from home and traveling less and so on and so forth. And whether you have any thoughts or comments on that from your perspective, how that relates to routing security.
Yeah, so I don't have completely empirical data for this to sort of definitively say that incidents have gone up or down because of COVID-19. One thing is definitely for certain is that traffic has increased a lot because of COVID-19, and you've certainly seen that in particular countries as well. We've seen that from sort of different data from IXPs and from operators that there's been a huge increase in traffic. So you might sort of think that that would cause a proportional increase in the number of incidents as well. But actually, the data that we've seen show a decrease in incidents. So, is that because people are being more responsible? Is that because network operators are actually actively taking routing security measures? Very difficult to say, but we certainly know that operators are really taking routing security. Some of the large operators are taking routing security much more seriously and actually actively implementing. So we've seen this because we've been working with them. Some of the largest ISPs have come to us, and we've been working with them to improve their routing security. So I think that has really had an impact, just anecdotally, just from what my discussions and from what we've been observing.
Thank you for that. And then a final question here is how often one needs to check if a network is hijacked or leaked, if there's any frequency there, or if you can provide some comments on that.
Well, how long is a piece of string? I think, for a large network, probably every day, perhaps. And certainly the observatory, it rolls over every day. So, it's not real time, but it's usually within 24 hours, you'll see something. I would say if it's a major leak, you'll know about that pretty quick as an operator, because everyone will tell you. We had last year where there was it was a misconfiguration from a very large provider, which I'm sure people in the business would know what it was, and they pretty much, it was pretty obvious to the rest of the internet very quickly, because of course traffic got dropped from a number of content providers as well, so they were up in arms, saying, oh, traffic's not reaching us. So you'll be certainly told, but what perhaps is, it's the stuff that maybe the route leak stuff that may not necessarily be noticeable, and traffic's not taking an optimal path, that might not be so noticeable if you're not doing not actively monitoring. So I mean, certainly for a network of any significant size, I think probably this should be looked at every day. But it just sort of depends on what the impact is, as to how noticeable this would be.
Okay. Thank you so much, Kevin. And those were all the questions that we've received. If anyone has any further questions, feel free to reach out to either Kevin or email through the follow-up email that will come from the webinar platform shortly. And I also want to extend a big thank you to you, Kevin, from Telia Carrier's side for providing this really interesting presentation for us today. So thank you so much.
Yeah, just to mention that the second part, the more in-depth technical configuration guide, will be on the 9th next week. So yeah, please join us for that.
Yes, for anyone who hasn't registered, it is available through both Telia Carrier's website and on Telia Carrier's social channels, and as well for the Internet Society and MANRS, both social channels and the website. So feel free to go to whichever of those you prefer. And thank you so much, everyone, and have a great rest of your day.